Hello everybody, it's Eben, and today I'm going to show you some theorems in Blaisdell circle notation and how you can use them. So the first one that I think is very interesting is 2n2 equals 4. And another one that there is x n y n plus 1 z is equal to x n plus 1 z n y n plus 1 z. And another one is x n y n plus 1 negative 1 is equal to x half circle n y. So what do these mean? Well, what you can do is you can plug in different values for n and it'll start to make more sense. So let's plug in a 1 for n here. It means that 2 plus 2 equals 4. Well, that's not really anything impressive, but this can also mean different things. If you put in a 2 for the n, that means 2 times 2 is equal to 4. Also true, but it's also not super impressive. What if you put in a 3? That means that 2 squared is equal to 4. Okay? But what's cool is that if you put in a 4, if you take the tetration of 2 for 2, that is 4. And no matter what it is, if you take two 2's, it will always come out to be 4. So even though when you plug in specific numbers, it seems very obvious, this says that for any number, it will work all the time. So one line can mean all these different lines, which is the kind of generalization that you can do with Blaisdell circle notation. Now what about this one? Let's put in a 1 for n. So that means that this will be x plus y. And n plus 1 would be 2, which would be multiplication. So n plus y times z is equal to x, n plus 1, that's multiplication, so x times z plus, because n is 1, y, n plus 1 is 2, so y times z, which is true. You just multiply it out, and you get that. What if you put in a 2 for n? That means that xy to the power of z because 2 plus 1 is 3, so it is exponentiation, is equal to x3z, which would be x to the z power. And then if n is 2, it's going to be multiplied by y to the z power, which is also true. But this works for infinitely more things, because n could be any value. Now over here, this involves negative numbers. Let's put in a 1 for n. X plus y, n plus 1 would be 2, so that's multiplied by n times negative 1 is equal to x half circle 1 is minus y. And this is true, because x plus a negative y is equal to x minus y. But you can also put in a 2 for the n, which means that x times y to the negative first power is equal to half circle of 2 is x over y. So, that is also true because that is a reciprocal of y, because it's to the negative first power, which would end up being that. So, again, this works for infinitely many cases, because n can be any number. And that means if you take the negative 1 tetration of a value and exponentiate that, that will give you the not square root, but the root. So you can generalize different theorems to have infinitely many implications.